Good evening, everyone. My name is Eedukondalu D. Title of my project is Feature Selection based on L1 norm support vector mission and effective recognition system for Parkinson disease using voice recordings under guidance by Dr. GNR Prasad sir. And this is my abstract. The main idea of my project is to identify the Parkinson diseases. Basically, it's a neurological disorder. So our system helps to identify the diseases in early stages. So the as an input of this is architecture flowchart. We are importing the Parkinson disease data set, and after that is goes to data preprocessing, and by using L1 arm support vector mission based on the features on data, it is subcategories, and it will test and training, then goes to applied and support vector mission. Is in SVM trying to k one of the folds along with the hyperparameter c and y, and then predict the model. Then k greater than or equal to go to average of 10 prediction. Then, no to go split the reduced substance of features, and average of 10 prediction outputs best predictive model. Then go to healthy people and PD people. This is use case diagram. Use case diagram, we have actors and use cases. This is actor, one user. This is use cases. First one, import modules and import data sets and data preprocessing and future extraction, and split data, train and test, model building, train model and predict. Then this is class diagram. Classes in class diagram are represented by boxes. There are three. Top one is content class name, and middle one is attributes, and third one is functions. First user, and then goes to modules and data set and pre-processing and future in engineering. Then data partitioning and model and predict and result. And this is sequence diagram. It represents a timelines which begins and the top, and to make the sequence of interaction. This one is object symbol, and those are in object symbols. First one, import data, second one, load to data set, and third one, pre-processing, and fourth one, operations, and fifth one, build, and sixth one, this is synchronization message symbol. This symbol is used to when a sender waiting message and response to message. And this is collaboration diagram. Collaboration is a collection of named object and actors with links and connection. This one is links, and this one is objects. First one is import data in modules. Second one is load data in dataset. Third one is pre-processing in. Fourth one, operations, and fifth one, build in model. Sixth one is result. This is activity diagram. An activity diagram usually present a series of actions or a flow of control. The diagram will have end. This one is end, begin. This one is end, and this is activity. This is the action of flow. This is synchronization bar. Then this one is a fork node. Fork node means split single incoming flows into multiple flows. This one is a join node. Multiple nodes split into single node. First user, then dataset. Dataset split into pre-processing and feature engineering and model building. Then goes to predict. Component diagram. Component diagram is used to break down a large object-oriented system into a smaller components. This one is called the rectangle box with components name contains component names and icons and stereotypes. First one is server, then goes to dataset and modules and algorithms, connection with algorithms. This is state chart diagram. First one, this is begin, and this one is end. This is flow of control. This one is first. First one modules and dataset and pre-processing and feature engineering. Split data is split in model building and predict. This is example in dataset. After change of the column names, then goes perform measures with different parameters. And this is algorithm pseudocode. First one begin. Step one, create an instance XI of the dataset. Step two, apply CV test for each instance for adjusting regularized hyperparameter C and Y. Step three, using L1 norm support vector mission on each instance of calculate weight of vector A for each feature. Step four, remove the feature who coefficient A equal to 0 in each instance. Fifth one, compute the average CV score for each instance. Sixth one, repeat step 2 and 5 up to that no features A equal 0 for the all each instance of dataset. Seventh one, choose the dataset, choose the subset of feature for each instance of the dataset who cross validation score value are high. Step 8, combine all remaining features into a new reduced set of features. Ninth one, produced X to reduced feature set of X that includes feature in K. Last is 10th one, finish. The system specification, software requirements, OS, Windows, and Python IDE. Hardware requirements, RAM 4 GB and higher, processor Intel i3 and above, hard disk 500 GB minimum. Thank you, sir.